in a switching network or in a normal, in an enterprise network, we have this concept of broadcast domain and the collision domain. So typically when we connect multiple devices, let's say we have some switches here, like one switch is here, a few PCs are there, we have connected all them like that. And so this by default, if I want to send some broadcast message, if I broadcast something from here, the switch is going to receive that broadcast, and it is going to just flood that broadcast out of all the interfaces except for the interface where the broadcast frame was received. So this is what we refer to as a broadcast domain. So what is a broadcast domain? Broadcast domain is more like a group of devices reachable via single broadcast. So if I send a broadcast message, that broadcast message will be delivered to how many number of devices? The group of those devices is what we refer to as the broadcast domain. So broadcast domain is a group of devices reachable via single broadcast. Or in other terms, like if I send the broadcast message from here, like from one of the device, that broadcast message is going to how many, it is reaching to how many devices. That is what we are going to refer to as the broadcast domain. So switches by default, like they have one broadcast domain, like all the devices that you connect via switch, no matter if it is a router, no matter if it is another switch, no matter if it is a PC, server, any device you consider, all the ports of the switch by default belong to the same broadcast domain. That means you can just connect like the devices on any of the ports onto this switch, and we will be able to reach from one device to the device by the means of broadcast. So by default, it is the default behavior. By default, all the ports of the switch, they are in the same broadcast domain. Sometimes it might not be necessary to have this kind of deployment. I do not want to have like all the ports in the same broadcast domain. Maybe I want to have like, I want to create some different broadcast domains. That is, in case of switches, it is possible to create multiple broadcast domain. If you want to create multiple broadcast domain, what typically we do, we connect a router, because router is a device where if we have like 4 ports, all these 4 ports will belong to one broadcast domain, like individual, like one broadcast domain, one broadcast domain, one broadcast domain, and one broadcast domain. So router, the ports on the router that we have here, the ports on the router, they belong to like one individual broadcast domain. Like if a router has 4 ports, there are going to be 4 broadcast domains onto the router. Typically, one broadcast domain, it means like one network. One broadcast domain, typically, we mean that one network. One broadcast domain, one network, one subnet, whatever you call that, it is all the same thing. So if you want to create multiple broadcast domain, let's say we have, for example, this is a switch, and here we have a few devices connected, and I want like these 2 devices should belong to one broadcast domain. I want that these 2 devices should belong to a second broadcast domain. So how, like because I don't want them to communicate to each other. So what I can do, I can actually connect these devices into a different switch. Like I can take like 2 switches. This is one of the switch, and this is the second switch. I have connected like 2 PCs. I have connected 2 PCs here, and then I have connected 2 PCs here, and I'm going to connect them with the help of a router. So this is going to be one broadcast domain, and this is going to be another broadcast domain. Packets from one broadcast domain by default cannot go to the other broadcast domain. If I broadcast something, the router is not going to forward the messages, broadcast messages received on one interface out of the other interface actually, right? So as we know here, router is the device that creates the broadcast domain. So if we want to create multiple broadcast domain, what we can do actually, we can have multiple routers connected to it. We can connect multiple routers, and by connecting multiple routers, we can have multiple broadcast domains. That is the way. But again, like in switches, in modern day switches, like, modern campus local area network solution includes devices called switches. And in switches, we have the capability to create multiple broadcast domain. In switches, we have the capability to create multiple broadcast domain without connecting it to the router. Means like we can actually create multiple broadcast domain just by some configuration command. On the switches, like in modern day network catalyst switches, they have the capability to create multiple broadcast domains with the help of some configuration commands. We can break the broadcast domain of a switch into multiple broadcast domain just by some commands I do not need to attach, I do not need to purchase multiple routers, and I do not need to purchase them via router. Well, I do not need to purchase multiple switches and connect them to the router. I don't need to do that. I do not need to purchase multiple switches to create multiple broadcast domain and connect them to the routers. I don't need to do that. I can just use some configuration command, and using those configuration command, what I can do, I can, let's say, for example, have these two devices, these two devices, these two devices, or more than two devices. Let's say, for example, these four devices, I can make part of one broadcast domain. These two devices, I can make part of another broadcast domain. These devices, I can make part of some other broadcast domain. And that all can be done just with the help of some configuration commands. So what exactly is the VLAN? VLAN, virtual local area network. VLAN or VLANs are the broadcast domains created through configuration command. VLANs are the broadcast domains that we create on the switches with the help of the configuration command. We use the VLAN to partition one broadcast domain into multiple broadcast domains. So we have a switch, we have a few, like we have here, we have a switch, and we have, like, for example, two devices here, two devices here, two devices here. I can make them part of one broadcast domain. I can make them part of the second broadcast domain. I can make them part of the third broadcast domain. So they can communicate, but they will not be able to communicate to like each other, like in devices in one broadcast domain cannot communicate with the other broadcast domain devices. Right? So VLAN, by definition, what exactly is the VLAN? Broadcast domain. Broadcast domain is a set of LAN connected devices in which when a device sends a broadcast, all devices get the copy of that particular frame. So generally broadcast domain are generally a local area network, and the broadcast domains are the same thing. So in general, a group of devices reachable via single broadcast, they are said to be part of the same broadcast domain. A group of devices reachable via single broadcast is what we call as a broadcast domain. Broadcast domain is a group of devices reachable via single broadcast message. So if I broadcast a message from here, that message will be delivered to how many number of hosts? All those hosts are going to become part of a single broadcast domain. Similar to the broadcast domain, we have this concept of collision domain. What is this collision domain? Collision domain is again a network segment. Collision domain is a network segment connected by some sort of shared media, such as, let's say, a hub, where simultaneous data transmission collide with one another. So let's say we have multiple devices, and we have connected these devices via a device called hub. And if I try to transmit the data from A to B, I try to transmit the data from B to A at the same time, the data will collide onto this hub, creating some problems. So collision domain, a collision domain is a network segment connected via shared medium, where simultaneous data transmission collide with one another. So again, a group of devices affected by single collision are said to be part of the same collision domain. So if I transmit the data from A to B and at the same time B to A, right? So the traffic will be received by this hub. Since hub is a half duplex device, hub can either transmit or receive at one time. So when the frames arrive at the hub, it will cause a collision, and the number of devices affected by that collision is what we are going to refer to a single collision domain. So in other words, a group of devices affected by a single collision, they are said to be part of the single collision domain. Whatever devices are part of the same collision domain may involved in the collision with one another. Systems within the collision domain may be involved with collision with one another. The collision domain is a network segment connected by a shared medium, such as, let's say, for example, hub, where simultaneous data transmission collide with one another. System within the collision domain may be involved in the collision with one another. In other words, the group of devices affected by a single collision, they are said to be part of the same collision. Now, hub is a device that is by default single collision domain. That means all the ports of the hub will be part of the single collision domain. What do we mean by that? It means that if the collision occurs on any of the ports, it will in fact affect all the other ports as well. Like if the collision has occurred between A and B, all the other devices will also not be able to transmit the data. They will also have to wait for this collision traffic to clear, and then they will basically forward the data. So hub that we have this device called hub. Hub is a single collision domain device. That means all the devices that you connect with the hub, they become part of one collision domain. And what do we mean by this one collision domain? It means that if I send the traffic from here to here, and at the same time, maybe from here to here as well, and if the collision occurs, the collision will not only impact these two devices, but it will impact the other devices as well. They will also stop transmitting the data, and they will wait for random amount of time before trying to transmit again. Right? So broadcast domain is a set of LAN connected devices in which when a device sends a broadcast, all devices gets the copy. A group of devices reachable via single broadcast is said to be part of a broadcast domain. A group of devices affected by a single collision, they are said to be part of the same collision domain, right? So we have this concept of broadcast domain, collision domain. Hub device that we have, it is a single broadcast domain, single collision domain device. Switch device that we have, it is single broadcast domain by default, bridge device that we have, it is a single broadcast domain and per port collision domain. Means if the collision happens on one port, it will not affect the other port. And then we have switch, like it by default, it is part of one broadcast domain, and again it is per port collision domain. That means if the collision happens on one of the port of the switch, it will not impact the other ports. Other port will keep operating as it is. And then we have router. Router is like one broadcast, router is like per port broadcast domain and per port collision domain. Like on the router also, if the collision occurs on one of the port, it will not impact the other ports, and all the ports on the router, they belong to a different broadcast domain. And these things can be simulated, just in case if you want to see all these things can be simulated very well in this software that we have in our CCNA studies. We have this software called Cisco Packet Tracer. I hope you guys remember. So these things can be simulated very well. Like if you want to know about all these things can be simulated very well in this packet tracer environment, right? Just to show you, then in 5-10 minutes, just to show you, I'm going to take a few PCs here. So this is these are two devices on the first floor. These are two devices on the second floor, and these are three devices on the third floor, right? And we were supposed to connect these devices. So what we used actually to connect these devices, we went ahead, we utilized like hubs here. In the networking devices, we have this device called hub in the third place. So I'm going to use a hub, I'm going to use a hub, and I'm going to use a hub. So to connect these devices together, we are going to use hub. So something like that we have used to connect devices like that. So first floor local area network, second floor local area network, and the third floor local area network. We have like these three networks, and now we want to connect them together as well. So we can connect like see how many ports this hub actually has. This hub has like a lot of ports, 6 ports there are. So I can also connect it like with the help of some other hubs as well. So right, I have configured like 2 hubs, maybe at the, you are following the same core distribution and access, you are following that kind of concept actually. But this topology that we have created, it is purely based on the hub. Like this is based on hub, right? Or like if you don't want to have this that complex, you can just connect it via one single hub. It will just work fine, no problem. Like that. So we have connected like first floor, second floor, and the third floor of my organization with the help of a device called hub here, which we really should not have done. But let's say we are using this device called hub to connect multiple devices together. Let's configure quickly the IP address on these devices. So it is 10.0.0.1 or whatever IP, 10.1.1.1, doesn't matter. Here it is going to be 10.1.1.2. Here it's going to be 10.1.1.3. I could have just connected a DHCP server, would have worked properly, but no problem. 4, 5, 6, 7. I'm going to configure. Now, ideally, if you send the traffic now, you will see that the traffic will be successful. Like there should not be any problem. We have configured IP everywhere to everywhere. I can just go on this device and I can go to the command prompt and I can just ping 10.1.1.1, ping is successful, 2 successful, 3 successful. Like you can connect to all the devices like 4, 5, 6, 7. You can connect, like you can ping all the devices and you will notice that the ping reply, it is successful. You can also check it like you can also check this thing via this here on the top. We have this packet. I can click on this packet. I can drop it on the source destination. I get the message successful here. I can drop it from the source to the destination. I get the message successful here, like here to here successful. So I can check it from here as well. Now see, let me show you. I said this is a single broadcast domain. All the devices connected via hub, they become part of a single broadcast domain. That means these two devices, this device, and all the rest of the devices, they are still, this is one single broadcast domain. This is one big single broadcast domain. Now, let's try to see how this hub is going to forward the traffic. Remember that hub always performs flooding. Hub is a device that cannot learn the addresses such as MAC address and all. Hub cannot learn it actually. So since hub cannot learn it, you will notice that hub will always perform flooding. So if I go to this simulation mode to check like how the packets are going, I can go to this simulation mode button here. I can go to this simulation mode button here, right? And from here, I can just now drop a packet from source to the destination. You will notice that a packet is generated. If I do capture forward, you will notice that the packet will arrive on the hub. Now, hub cannot learn anything. Hub is more like a network device that is responsible to more like flood the frames out of all the ports except for the port where the frame was received. But the point is here, when the hub receives that particular frame, it is just going to flood it. So it will be received by this device as well as this device. Now this will flood it. So again, it will be received by this device. Meanwhile, the reply that comes, that will also get flooded. So you will notice that some sort of flooding has happened. These will drop it, these will drop it, because the packet doesn't belong to them. So, and when the reply comes, this is also going to be flooded. That is how hub works. Hub is always going to perform the flooding. It is more like a layer 1 device. It is more like a not so intelligent device. It cannot learn the addresses and everything. So you will notice that this kind of flooding will always happen in hub. That is not the problem. Okay, at least flooding is happening. That is not the problem. At least we are able to ping from one device to the device. That was our main aim. So it is not a problem that the flooding is happening. That is not the problem. The problem is this. The problem is if I send the traffic, for example, if I send the traffic from here to here, and at the same time I send the traffic from here to here, right? These two traffic flow has like they have no connection to each other. They are two different flows. This communication is different than this communication, right? So see how the packet will go. If I do the capture forward, packet will arrive on this hub. This hub is going to flood it. Once it floods it, it will be received by this device as well as this device. Same, this hub is going to flood it. So it will be received by this device and it will be received by this device. The problem is when the frame arrives on here, right, it will cause a collision. It will cause a collision. This is the way they choose to represent collision in a broadcast domain. So in this packet tracer environment, you see these kind of packet, catching fire, representing that the packet has collided with the frame has collided with the other frame, right? Now what will happen? Remember that this traffic has nothing to do with this traffic. When the frame arrived on this particular hub, it collided with the another frame. And now what will happen? This hub is going to tell everyone about it. It is going to tell that a collision has happened, stop transmitting the data. So this message will be flooded to everyone in the network, all the devices end to end, all the devices will receive that traffic, all the devices will receive that information that the collision has occurred, and they will stop transmitting immediately. They will now wait for a random amount of time before choosing to forward the data again. So collision happened here and all the devices got affected. That is why we call that this is a single collision domain. This is a single broadcast domain and this is a single collision domain. Even though, let's say, for example, I try to transmit from device A to device B and device B to device A, there also the same thing will happen, right? So if I go like here to here, and at the same time here to here, like both the devices try to transmit the data at the same time, you will notice still in this case also the packet will collide here, collision will occur, and not only these two devices will get affected by it, all the devices will get affected by it. So see, all the devices will get affected by it. So this is what we refer to as a single. This is what we refer to as a single collision domain. Collision domain is a group of devices affected by a single collision. Broadcast domain is a group of devices reachable via single broadcast. So devices such as hub, they are by default single broadcast domain, single collision domain, and you cannot change it. You can't do anything about it. This is how they will behave. That is why it was not a very beneficial. It was not a very good idea in a medium to big campus network that we use these hubs there. It was not a very good idea. But at that time, at that moment, in those time periods, like hub could have been the only device to do that. So we had no options actually. Later, they invented this device called bridge. So what I'm going to do now, I'm going to remove this here. This hub I'm going to remove, right? And I'm going to connect a bridge here. So I can go to this networking devices. I can go to the switches option. And right here, I have this bridge, PT bridge, packet tracer bridge. And I can just connect it here. This is the symbol of the bridge. Now, the problem is that in this bridge, we only have 2 ports, right? This bridge only has 2 ports. Like it was supposed to connect 2 segments together. So this bridge actually has only 2 ports. So I will be able to show you that only in between these 2. But anyway. Now, bridges were intelligent devices. If I just click on that now, bridges were intelligent devices. Like bridges comparatively, they were intelligent devices. They can run some protocols such as, STP and all. They can maintain the MAC address table and everything. Bridges were more like predecessors to the switches. Like, switches are successor to the bridged network. So we used to have the other devices such as bridge. If I want to connect a segment with another segment, I'm not going to use a hub. I'm going to use a bridge. 2-port, 4-port bridge we can purchase. Ideally, you will see 2-port bridge. And if you require to connect like more than that much number of devices, you have to go for the other options. This can learn, actually. This device can learn the MAC addresses. This bridge that we have, this can learn the MAC addresses, right? So I can, if I send the data from, let's say, from here to here, right, it will be successful. If I send the data from here to here, it will be successful. If I send the data from here to here, it will be successful. If I send the data from here to here, maybe it will be successful. And if I go to the packet capture, if I go to the simulation mode, and if I check all that thing, if I send the data from here to here, you will notice that hub, as usual, it is going to flood it. Bridge is going to send it towards the other devices. Hub, as usual, is going to flood it. This will drop, this will accept, and the reply will come in the same way. So bridge was also the device that we used to connect multiple devices in the same network, just like switch. And bridges, they do not unnecessarily forward the frames. So if I ping from here to here, traffic arrived on the hub is going to flood it. So the frame will be received by this device as well as this device. Now this bridge is not going to forward that frame unnecessarily here, because it knows that the source MAC address and destination MAC address, they are connected in this direction itself. It has learned the MAC addresses of the source and destination. It has learned the MAC address A and B on the port. So when the frame arrived here, having the source MAC address as A, destination MAC address as B, it sees the MAC address table and it says that both A and B, they are learned on the interface Ethernet 0x1. They do not exist on the other links. So it is not going to forward the frame out of the other interfaces unnecessarily. So comparative to the hub, the bridges were comparatively like intelligent devices. And just in case if the collision has occurred, you send the traffic from here to here, and at the same time you send the traffic from here to here. Just in case if the collision has occurred, you will notice that this bridge is going to forward the frame. The hub is going to tell everyone that the collision has occurred, but this bridge is not going to send that information to here. Bridge, see, drops it. Bridge is a per port collision domain device. That means if the collision has been detected onto a port, it will have no impact on the other port. That is why we call it a per port collision domain device. Right? So there were a lot of advantages of using this device called bridge in a switched network. Sorry, there was a lot of advantages of using this device bridge in a bridged network, not the switch network, because at that time switches were not even invented. Still, it is a single broadcast domain. The problem with the bridge was that we actually cannot create additional broadcast domains. Bridge was a device that we can use to connect multiple segments together, but bridge, we cannot actually configure multiple broadcast domains onto that particular bridge. It is also more like a software device. So there was a software implemented on this device that takes all the forwarding decisions on the bridge. Right? So single broadcast domain, per port collision domain, we get on this device called bridge. Hub, single broadcast domain, single collision domain, always we have on this device called hub. Then they advanced the technology, and then they created switches. Switches were just multi-port bridge. Switches were basically just multi-port bridges. So actually all the functionalities that bridges had, all those functionalities were there on the switches as well. So we can purchase a basic switch like 2950 series Catalyst switch platform, or an high-end 3650, 3670, whatever switch platform you can purchase, and you can use it to connect these segments together with the help of switch as well. And just in case if you want to create multiple broadcast domain, now we do not need to connect a router to create multiple broadcast domain. I can just simply create this thing called VLAN. VLANs on the switches, they allow us to create like multiple broadcast domain with the help of configuration commands. Right? So switches has the same property, right? What properties of the switches are there? Already we have talked about it, not going to talk about it again. Address learning, filter and forwarding decision, loop avoidance, all those functionalities are there on this device called switch. And hope you remember, like switch is also a device that is a per port collision domain device. That means if the collision occurs, like if, let's say, for example, the collision has occurred, let's say the collision has occurred between on a certain port on the switch. Let's say the collision has occurred onto this particular port. Someone has notified that the collision has occurred onto this port. The switch is not going to forward that message out of this port or out of this port. So this port is a different collision domain and this port is a different collision domain. right? So all the properties that we get on the bridges, those properties were here on the switches as well. Switches were more like successor to the bridges. It was just more like, it is more like a multi-port bridge. It is more like a multi-port bridge that they created, having some additional functionality, such as the creation of the VLAN, that we can create the VLAN to create additional broadcast domain with configuration command. We do not need to connect any router for the same. It is per port collision domain and a single broadcast domain device by default, and all these kind of things were there on these switches. So you can simulate the things very well in this packet tracer software, and you can check about the broadcast domain, collision domains, and all that thing. Now, so like I said, we can create VLANs to break the single broadcast domain of the switch into multiple broadcast domain. A VLAN is any broadcast domain created through configuration command. One VLAN, one broadcast domain. One broadcast domain, one network. So one VLAN, basically, let's say, for example, I put these two ports in one VLAN and I put this port in a different VLAN, right? So there are going to be now two broadcast domain. This is one broadcast domain. This is a second broadcast domain. So this will become one broadcast domain, and this will become a second broadcast domain. And I can do it just with the help of configuration commands. I do not need to use a router to create additional broadcast domains. So VLANs are broadcast domains created through configuration commands. Switch has the ability to put one port in one broadcast domain, another port in another broadcast domain, and some sort of segmentation can happen at layer 2. Traffic that arrives on one port cannot go out of the other port in a different broadcast domain, not at least by default. Right? So we can create VLANs to break the single broadcast domain of the switch into multiple broadcast domain. A VLAN is any broadcast domain created through configuration command. One VLAN means one broadcast domain. One broadcast domain means one network. So every VLAN is now these new additional broadcast domains that you configured via configuration command. These additional broadcast domains that we configured, that we created via configuration command, they are going to be numbered. Like we can, how can we identify these new broadcast domains? So we can identify these broadcast domains by a number, and that number can be any number from 1 to 4094. Every VLAN is represented by a number starting from 1 to 4094, and every broadcast domain, every VLAN can also be given a name just for ease of understanding. I can give a name to a particular broadcast domain as well. I can give a name to a particular VLAN as well. Right? By default on Cisco Catalyst switches, VLAN 1 is the default broadcast domain. Like all the ports in Cisco Catalyst switches, they belong to a same broadcast domain by default. And that is why we can actually, ping from one device to another device without doing any configurations onto the switch. Like whatever device I connect with this port, whatever device I connect with this port and this port, all of them will belong to the same broadcast domain. All of them will belong to the same broadcast domain. All of them will belong to the same broadcast domain. And we will be able to ping from one to another easily. So actually, by default, all the ports of the switch, they belong to same broadcast domain, and that is VLAN 1 by default. That is virtual local area network 1, VLAN 1 by default. So VLAN 1 represents the default broadcast domain of the switch. And by default, all the ports on the switch, by default, they belong to the same broadcast domain, VLAN 1. We can also have we can have data VLAN, voice VLAN, wireless VLAN in our network. We can connect, for example, a switch with an IP phone, and I can place this in a particular VLAN to support our voice traffic, to support our data traffic. We can also have, let's say, for example, an access point connected here, and that port I can configure as a trunk port or as an access port. So all the, it will more like a particular a particular user that connects itself with the network in this SSID ABC is automatically going to be part of the VLAN 10. So we can also map the wireless SSIDs with the particular VLAN as well. You will study this someday in the wireless track, not in our content. Voice, we don't need to talk about that. Wireless, we don't need to talk about that. So we can have like data VLAN to support the data traffic. We can have voice VLAN to support voice traffic, and the wireless VLAN to support the wireless traffic. Every port still represents one collision domain, no matter how many number of VLANs create. Means like overall number of collision domains will remain same. Like overall number of collision domains will remain same. What do we mean by it? Let's say this is VLAN 1, this is VLAN 2, and this is VLAN 3. Doesn't matter. We have configured 3 broadcast domain by creating 3 VLANs. But this, there are going to be like 3 collision domains. Number of collision domain overall will remain same. Number of collision domain overall will remain same no matter how many number of broadcast domains you create. So earlier, this was like 1 broadcast domain and 3 collision domain. Now we configured VLAN. So this is now like 2 broadcast domain and 3 collision domain. Now then we configured like this. So this is now more like, this is now like 3 broadcast domain and 3 collision domain. So overall number of collision domain will still remain the same, no matter how many number of broadcast domains you create. Like creating the VLAN doesn't cause any changes in the collision domain. Collision domain will always remain the same onto the switches, no matter how many number of additional broadcast domains, additional VLANs you actually create. Right? Fine. Any doubts? Anyone? Let me know. Any questions? Anyone? So far, it's just basic. You might already have understood everything in the previous CCNA, CCNP studies. So it's more like a revision. All like that, if you don't have any doubt. There are 2 like ranges for the VLAN. Like we can create the VLANs from 1 to 4094. When it comes to the range, there is a normal range VLAN from 1 to 1005. VLAN 1, 1002 to 1005, they are reserved. VLAN 1 is the default VLAN in the Cisco Catalyst switches, and 1002 to 1005 are unsupported on Cisco Catalyst switches. These VLANs were originally like these are FDDI token ring VLANs. So when we used to have these FDDI token ring network, there we used to actually use these VLANs like 1002, 3, 4, 5. But in a modern day Catalyst switch platform, you will notice that these VLANs are unsupported. These VLANs in a modern 1002, 1003, 4, 5, these VLANs are actually unsupported VLANs. So if I use the command, let's say, for example, if I use the command show VLAN brief, I will be able to see what VLANs are there by default onto the switch. So I went ahead on the switch and I'm checking like the command show VLAN brief. Command is show VLAN brief. If you don't use the brief keyword, it will give you the information in very detail. So about the VLANs, everything and all, like all the types of VLAN that you can have. It will show you the basic VLANs, then it will show you remote span VLAN, then private VLANs and all. So it will show you all that. Generally, we use the command show VLAN brief to get the idea about the VLANs configured in the network in brief. So in the show VLAN brief, it says like VLAN 1, 1002, 3, 4, 5. So this is the default VLAN. All the ports belong to the default VLAN. 1003, 2, 3, 4, 5. They are unsup. Unsup means unsupported, but we cannot delete it. Even though these are unsupported, but we cannot delete it. These are used for FDDI token ring, FDDI network, token ring network. So these were being used originally for FDDI and token ring technologies. So these VLANs were originally intended for bridging with the FDDI and token ring network. But as the data link layer technologies are, these technologies are not used anymore, these VLANs are unused. So like VLAN 1002 to 1005, they are unsupported on Cisco Catalyst switch platform. However, because of the backward compatibility reasons in IUS and VTP, these VLAN numbers remain reserved and cannot be used. Like for the backward compatibility, maybe somewhere still we are using these technologies such as FDDI token ring. So just for the backward compatibility purpose, they still have that VLAN, they still have those VLANs created. So But by default, like we cannot actually delete it, we cannot modify it, we cannot do anything. These are reserved ranges, so we cannot do anything about it. We cannot there are total 5 default VLANs, VLAN 1 and 1002 to 1005. We can't do any changes into those VLAN. For example, if I try to go configure terminal, if I say VLAN 1, try to do shut it down, it's not allowed. Try to change the name, it's not allowed. You try to delete that VLAN, it's not allowed. You try to delete VLAN 1002 because you think it is not in use, not allowed. Name, you can not change. We cannot do anything on these default VLANs. We cannot do anything. So normal range VLANs that we have, this is like from 1 to 1005, 1002 to 1005, they are reserved. When these much number of VLANs were not sufficient in a modern day network, like they configured an extended range of the VLAN as well, that starts from 1006 and it goes all the way to 4094. So we also have, apart from the normal range VLAN, we also have this thing called extended range VLAN, and it starts from 1006 and it goes all the way to 4094. It is just more like an expanded range of the VLAN. There's nothing special about it. It's not like if I put a port in VLAN 1100, there will be something special treatment for these. It's nothing like that. So extended range VLANs, they are used just like normal range VLAN. Just like normal VLANs, we use these extended range VLANs. And these are automatically used by the switches as well when we use the switch port, no switch port command. So these are also used for internal uses by the switch when we change the layer 2 to layer 3 port by using the command no switch port. This we have already talked about in our second class. You can watch the recording for the same. When I change the port from layer 2 to layer 3 using the command no switch port, there also switch is going to use a VLAN from this range for that purpose. This is what we call internal uses. So within the same VLAN, communication is possible. Inter-VLAN communication is possible, but inter-VLAN communication is not possible by default. For inter-VLAN communication, we need to perform inter-VLAN routing using a router or a layer 3 switch. So total range goes from 1 to 4094, divided into two parts: normal, extended. Normal range VLANs 1 to 1005, 1006 to 4094. These VLANs you can create on all switches. But will you be able to create these VLANs on the switches or not? That is dependent on the configuration of a protocol called VTP, VLAN trunking protocol. So there is a protocol called VTP, VLAN trunking protocol, which we will study later on. Based on the configurations of VTP, either we will be able to create these VLANs or we will not be able to create these VLANs. So for example, if I want to create the VLAN, I can say like VLAN, and I can create the VLAN from 1001 to 4094. I can create VLAN 2, 3, 4, I can do that. But will we be able to create the extended range VLAN such as 1100 or not? This is dependent on the configurations of a protocol called VTP. VTP stands for VLAN trunking protocol, right? So if I use the command show VTP status, here, based on this configuration, either you will be allowed to create the VLANs, those extended range VLANs, or you will not be allowed to create the extended range VLAN. We will talk about that in our VTP classes. This is extended range VLAN. Also note that until you exit from this configuration, changes are not done. Changes are not created until you exit from here. So if I say do show VLAN brief, I cannot see that VLAN 1101. Even though it looks like I have configured it, looks like I have created it, but it's not there. Because until you exit from this VLAN configuration, changes are not done. Like until you exit from here, the changes are not done. So if you exit, now you will see that in the show VLAN brief, now you will see that the VLAN is actually created. We can define the name for the VLAN. We can do shutdown on the VLAN. We can do no shutdown on the VLAN. So you can do all these things as per the requirement, but changes will not be done until you exit from this particular configuration. Yes, let me know.
Sir, actually, can you pardon that? Actually, I didn't get that what you said. Can you explain, sir, once that it was not showing the 1101 before, but after that it was starting showing.
No, I said, like, let's say, for example, I configured this VLAN 1101, like
Okay.
1100. I created this VLAN, but I did not exit from the VLAN configuration. So until I
Okay.
exit from this VLAN configuration, this VLAN will not be created. Once I exit from that configuration mode, VLAN configuration mode, now the VLAN will be created.
Okay. Means we need to first of all we need to get back.
Like you created the VLAN, but until you exit, this VLAN will not be created.
Okay. Okay. When we'll get exit, that time it will be show.
Yeah, then like it will create the switch will create the VLAN. So at the moment we are in the VLAN configuration mode. We are at the moment in the VLAN configuration mode. We can configure other parameters as well. There are a lot of parameters that you can configure regarding that particular VLAN. But like, for example, name you can configure. For example, you can do shutdown, you can do no shutdown. You can configure other things for that particular VLAN. But
Yes.
until you exit from this mode, the VLAN will not be created and changes will not be done.
Okay. Okay.
So,
Okay. Sir.
so you exit. Now you will notice that the switch will finally configure the VLAN onto the device.
Got it. Thank you.
All right. So this is how we create the VLAN. Nothing special. VLAN, name, exit. Note that VLANs are created only after we exit from the VLAN configuration mode. We can verify it with the command show VLAN brief. Now, let's say you receive a call from a customer and the customer says that, anyway, we can delete the VLANs like that. If you want to delete the VLANs, you can delete the VLANs like that, like that. So let's say you receive a call from one of your customer, and the customer says that we have a few users, and they are not able to actually access the resources. There are a few users, and the users are not able to access the resource. These users are actually not able to access the resources, and rest of the users are able to access the resources. So you said, okay, no issues. Give me the access. I will check. So you took the SSH access, or you took the telnet access, whatever. You took the access of that particular switch. Need not to be necessarily your client. It could be like your another branch. You got a call from an IT admin on certain branch, and he's saying that, okay, we are not able to actually, some users are not able to access the resources, but some users are able to access the resources. And that problem happened just suddenly, like time when the office closed in the evening, like everything was working fine, but in today morning we noticed that this problem is there. So now you said, like, okay, give me the access, I will check. So you went ahead with telnet SSH, right? And you use a few commands, like, you set the command show, uh, you use the command show run interface, like, okay, this user is not able to access the resources. Okay, let's check it. Turns out the problem was that the particular user was part of VLAN 99. The particular user was part of VLAN 99, but the VLAN 99 did not exist. Someone accidentally deleted that particular VLAN. This user is part of this. The user connected onto this port was supposed to be part of VLAN 99. So I use the command interface switch port access VLAN 99. The user was supposed to be part of VLAN 99, but when I am checking do show VLAN brief, I cannot see the VLAN 99 here. I see show run interface gig 1/0/9. I see that the user connected onto this port is not able to access the network resources. I found out that the user belongs to VLAN 99, but VLAN 99 does not exist. So remember, if it will not happen in Catalyst switches, it will not happen that if someone deletes the VLAN where a particular port is assigned, it will not happen that the port will go back to the default VLAN 1. It will not happen. Like if a port belongs to a certain VLAN, If the VLAN exists, then it's okay. But if the VLAN does not exist, in that case, the port will not jump to the default VLAN 1. It will remain there. It will more like be inactive. See, if I use the command show interface gigabit 1/0/9 switch port, if I use this command, if I use the command show interface gig 1/0/9 switch port, it says inactive. In Cisco Catalyst switches, at least it doesn't happen. In other vendor switches, you have to find out that thing yourself. Maybe in the Juniper switches, that might happen that if someone deletes the VLAN where a user is assigned to a particular port, maybe the port will jump back to the default VLAN. Who knows? But not in the Cisco Catalyst switches. On Cisco devices, it will just not happen. So you found out that why the users are not able to access the resources, because someone accidentally, same configuration was there on the port number 10, same configuration was there on the port number 11. You found out that those 3-4 users are not able to access the resources because those ports belong to VLAN 99 and VLAN 99 does not exist. So all you have to do is to just create the VLAN 99 and it will fix the problem. That is all that we had to do. But your client, your customer is not giving you the access to the configuration mode. Of course, they will not. So they are saying that, oh, I cannot give you the access to the configuration mode. Why? Because if I give you the access to the configuration mode, who knows like what changes you are going to make. I cannot give you that. So in that kind of situation, we also have another option to create the VLAN. We have another way of creating the VLAN actually. We can create the VLAN from the privilege mode as well. If you are not allowed to go to the configuration mode due to the policies, security policies or anything, I can create the VLANs from this privilege mode as well. We can create the VLANs from the configuration mode. We can also create the VLANs from the privilege mode. To create the VLANs from the privilege mode, you have to use the command VLAN database. Command is VLAN database, and from here you can create the VLANs. Remember that this command is not available on this version of Catalyst switch. This command was being deprecated. So in modern day switches, you might not see the support of this command. This is Catalyst 93,000 series switch, same. It is a physical switch. So here we do not have the option to create that VLAN from the VLAN database mode. But if I take the access of another switch, maybe this Catalyst 3850 series switch or 3850 or maybe a old switch as well. So I can try to access this Catalyst 3850 series switch. This is a Catalyst 3850 series switch. If I use the command VLAN database, here we don't have that command either. If I go for that Catalyst 3750 series switch, this is a Catalyst 3750 series switch. Just wait. So on some switches, we have this option. Like in modern day switches, you will not get that option. But in these old platforms, like you also have this option to create the VLANs from here itself. From here, like VLAN database. From here also, you can create the VLAN. See, VLAN database from the privilege mode. This command is being warning. It is recommended to configure the VLAN from the configuration mode, and as the VLAN database mode is being deprecated, and they have actually removed that in modern day switch platforms, please consult the user documentation to configure the VLAN in the configuration mode. But if you have an old switch platform there at that location, you can configure the VLAN from here as well. So VLAN database, and then I can create like VLAN 99, right? I can also lay like name I can configure. Some configurations I can do like that. I can say like shut down, like, these are shut or what these kind of commands are there. I'm not sure. There is also command like shut, no shut commands are also there. So you can refer to the documentation for the same, but the whole idea was that we can configure the VLAN like that as well. We can also create the VLAN like that as well. We can configure the VLAN something like that as well. So the command is like VLAN database. We can also configure the VLAN from this command like VLAN database. So VLAN database, VLAN 3 name, we can also configure like that as well. This mode is being deprecated, but still we have the option to do so. So there are more like 2 ways to configure the VLAN, but in modern day switch platforms, you will not see those 2 ways. You will see only one way to configure the VLAN nowadays, and that is just this VLAN configuration mode. Right? So if you have an old switch platform and you're not allowed to go to the configuration mode, maybe you can also use this VLAN database command to create the VLANs in the configuration mode, in the privilege mode. But as like they say, this mode is being deprecated. So if you have a very latest Catalyst switch, you might not get that option, just like we are not able to have that option. You're not having that option in here in the Catalyst 9300 series switch. Also remember that if I want communication from a device to device, VLAN 10 to VLAN 10, that VLAN must exist on all the switches in between. Means if I want that the user in VLAN 10 should be able to communicate with the user in VLAN 10 on these 2 switches, VLAN 10 must exist on here and here as well, because the traffic will flow like that, traffic might flow like that, traffic might flow like that. So VLAN 10 must exist here. If the VLAN does not exist, the traffic will be dropped by those particular switches. So VLAN must exist for the user traffic to flow via that particular switch towards the destination. So if you have like VLAN 10, VLAN 10, VLAN 10, you can either configure the VLAN 10 on all these switches manually, one by one, or you can use this thing called VTP, VLAN trunking protocol, to flood the VLAN information from one switch to other switch automatically. So either we can configure the VLAN manually, or we can use this VTP protocol, VLAN trunking protocol. We can use this VTP protocol to actually flood the VLAN information from one switch to another switch automatically as well. So what happens in the VTP? That we create the VLAN on system number 1, the information will be flooded everywhere automatically. So we don't need to administratively configure the VLAN on all these switches one by one manually. VTP again, it is a little bit risky protocol actually. VLAN trunking protocol, VTP, is again a little bit risky protocol to use in a production environment nowadays. So companies that use VTP, VLAN trunking protocol, they use it with very caution. Because just like creating the VLAN will make all the switches create the VLAN, similar to that, if I accidentally delete the VLAN from here, all the switches will delete that VLAN as well, and your user traffic will be affected as well. So VTP is a little bit risky protocol to use in a production environment. So we will see like what version of the VTP and everything we use in there. How can we configure the ports in the VLAN? How to configure the ports in the particular VLAN? If you want to configure the ports into the VLAN, to configure the ports in the VLAN, we have this option of either we can configure the port manually, or we can configure the port automatically in the VLAN. We have the option to configure the port in the VLAN either by static configurations or by using some dynamic VLAN assignment method. So once you have created the VLAN, now you have to assign the port to the VLAN. Now you have to assign the port to the VLAN. So VLANs are assigned on the port manually by the administrator, or port will remain part of the VLAN, and the port will remain part of the VLAN no matter which device connects to that particular port. So if I go ahead and configure, for example, FA 1 by 0 by 1 part of the VLAN 2, so anyone who connects to this port will become part of VLAN 2. It's more like a static configuration of the VLAN that we have done onto that particular switch port. So interface, switch port, access, this means data. This doesn't mean that the port is going to access the VLAN 2. It's not like that. This keyword I can change to voice to configure a voice VLAN onto the same port as well to support voice traffic. To support the voice traffic, we can configure switch port voice VLAN command, and switch port access. Access basically means more like data. That this port belongs to the data VLAN 2 and this port belongs to the voice VLAN 20, 30, whatever. If I configure the port into the VLAN 2, that port will remain in VLAN 2 no matter who connects to that particular port. That is more like this assignment, this static VLAN assignment is beneficial when we do not have the users roaming around the network, when the users are also more like static, when the users are also more like fixed at a certain location. So if the users are fixed at a certain location, if the users are static onto the switches, if the users are fixed at a certain location, in that case we can configure certain VLANs as per the requirement. I know that this user this user belongs to the HR. This user also belongs to the HR, and for the HR users, I have configured a VLAN 10. So I'm going to manually bind these ports in VLAN 10 so that when the user sits on here and the user sits on here, they will become part of VLAN 10 and they will be able to communicate to each other, considering that they are HR users. So static VLAN assignment is beneficial when your users are stationary. They are not, they are not moving. Basically, they are at the same location. But if the users are moving from one location to other location, let's say there is a manager, and that manager has the access to all the floors in the company: first floor, second floor, third floor, fourth floor, fifth floor. This manager can go onto any floor. It can connect its machine to any switch onto all these 5 floors. I want that this manager should always get the same VLAN membership no matter where it connects itself, right? No matter where it connects itself, I want that that particular manager to get the VLAN membership of the same VLAN, no matter where it connects itself. Why? Because for that particular VLAN, we have applied some policies, and based on the policy, this manager of traffic has to exit in the network. So I want that regardless of the location of the device, regardless of the physical location of the device, I want that the user should get the same VLAN membership. In that situation, this dynamic VLAN assignment is very beneficial. In this case, what we used to have a server called VMPS server, VLAN Management Policy Server. We used to have a device called VMPS, VLAN Management Policy Server. In this VMPS, in this VLAN Management Policy Server, we are going to create a database of the MAC address and its associated VLAN membership. I'm going to create a database of the VLAN membership for the particular MAC addresses. Now, when the user connects itself onto the switch, it will present its MAC address. This device is going to ask the VMPS server that MAC address B belongs to which VLAN. VMPS server is going to tell the switch that the B belongs to VLAN 10. So this port is dynamically going to be configured in VLAN 10. And let's say if the user connects to this port and the user has the MAC address C, this device is going to ask the VMPS, C belongs to which VLAN? Turns out that C belongs to VLAN 20. So the VLAN 20 membership is going to be assigned to that particular port. So we used to have a device called VMPS, VLAN Management Policy Server, which was again just a network switch, where we had a database of the MAC addresses and their respective VLANs. Like VLAN A, MAC address A belongs to VLAN 10, MAC address B belongs to VLAN 10, MAC address C belongs to VLAN 20, and then so on. So when a user connects to the particular switch, user will present its MAC address. Switch is going to ask VMPS based on the MAC address, tell me what VLAN this user belongs to. VMPS is going to tell the switch that the user belongs to this particular VLAN, and based on the same, the VLAN membership will be given to the particular port. Fine. Nowadays, we don't use this VMPS. Nowadays, we do not use dynamic VLAN membership assignment based on VMPS because we have AAA for that purpose. .1 export based authentication and everything we have in a modern day network. So we do not use this device called VMPS. Instead of that, we use AAA .1x based authentication. When the user will get authenticated, maybe based on the username and password. And based on the username and password, the user will be given the VLAN membership from that AAA server. These are the two ways that we can use to assign the VLAN to a particular port. How can we do it in our lab? So let me do in our lab. I'm going to go on this switch number 1, 2, 3, 4. I'm going to configure this port in VLAN 10, this in VLAN 20, this in VLAN 10, this in VLAN 30, this in VLAN 20, in 30, in 10, in here 30. This is the VLAN membership that we have to configure. It's easy. Just go on the switch number 1. First of all, create the VLAN. So enable configure terminal VLAN 10. Additionally, you can configure it with the name. Once you have configured the VLAN, then go to the port and say switch port access VLAN 10. Then go to the other, like create another VLAN 20, name, then exit, then say interface, 0/1, switch port access VLAN 20. So this is how we can configure the VLAN and we can assign the port to the VLAN. Simple. We can validate show VLAN brief. We can validate show VLAN brief. We can see that the VLAN 10, 20 got created. VLAN 10 is named as HR, 20 is named as IT. In VLAN 10, we have the port Ethernet 0/0. In VLAN 20, we have the port Ethernet 0/1. Now I will go to the second switch. This time, I'm not even going to create the VLAN. I can also directly go on the interface, switch port access VLAN 10. Interface access VLAN 30. So Cisco IUS automatically creates the VLAN. If the VLAN does not exist and you try to assign a port to a VLAN, Cisco IUS is going to create that VLAN and assign the port in that VLAN for you. However, the name of that VLAN will remain default, like VLAN, then 00110 003, like 1030. You can later on change the name as per the requirement if you want. If you don't need to change it, completely up to you. Right? So name doesn't matter. It's not like here we have configured the name HR, so we have to configure the name HR here as well. So it's just for your identification. Switch has nothing to do with it. Go to switch number 3, configure terminal, interface, switch port, access, VLAN 20, interface, switch port, access, VLAN 30. Go to switch number 4, here, interface, switch port access VLAN 10, and interface switch port access VLAN 30. This is how we can configure the VLAN, assign the port into the VLAN, or we can just directly assign the port into the VLAN. No need to configure the VLANs by commands. So if you do not actually care about the names and anything, like, in that case, you can just go ahead and configure it. You can just go ahead and configure it. But if you want to change the name or so in that case, like you can change the name and those things as per the requirement. This is static assignment, static VLAN membership assignment. Now you can check it by the command show run interface each 0 by 0, 0 by 1. You can check it like that. You can check it like show VLAN brief, like that as well. And you can also use the command show interface Ethernet 0 by 0 switch port. You can use this command show interface Ethernet 0 by 0 switch port. You can see that this port is a layer 2 port, belongs to VLAN 10. We have not configured any voice VLAN onto that port. If I want, I can go to that port, switch port to voice VLAN. I can also configure 20 maybe, 30 maybe, 100 maybe. You can configure a voice VLAN as well. So to support the voice traffic, we can configure the port with a voice VLAN as well. Now, if I say show interface Ethernet 0 by 0 switch port, I can see that there is also this thing called voice VLAN. So to support the voice traffic, we can also configure this voice VLAN. Command is switch port, voice VLAN. No need to worry about it because not part of our content. When you study collaboration voice video there, they will talk about this voice VLAN. When you study wireless, they will talk about maybe this port goes towards an access point, and I have configured this port part of the VLAN 100. So all the traffic that comes onto this particular port will become part of VLAN 100. Or maybe I have configured multiple SSID, whichever connects to SSID ABC will become part of VLAN 10, and whichever connects to the SSID XYZ becomes part of VLAN 20. That is the setting I have done on my wireless LAN controller, like my wireless LAN controller to the access point. So now I have to configure this port as something called a trunk port so that VLAN 10 and 20 traffic can be supported. So that is more like a part of a wireless deployment of the VLANs. And also when you study wireless, you will study about that. That is how we can create the VLAN and configure the ports into the VLAN statically, manually. Doubts any so far? Let me know. No, VMPS we are not going to cover. We don't use VMPS nowadays. So it's more like not supported, not used nowadays. So we use .1x port-based authentication, which is again part of security. Any questions so far? Anyone? Yes, Palkesh.
सर सेम VLAN अगर मैं कॉन्फ़िगर करता हूँ वॉइस और एक्सेस के लिए तो डेटा फिर कैसा सेग्रीगेट होगा?
That is the responsibility of the IP phone at the and all those things. So that configuration has to be done like if you want to put the port like in the same like VLAN for the voice and access, so that will create the issues. So ideally we don't do that, and we have different options to support the voice traffic onto the port. We have like .1p, we have like untagged, we have voice VLAN, we have different options for the same. So based on that, you need to configure. Okay. That will, your IP phone will come into the picture in that case. The connectivity is going to be a little bit different if you have connected an IP phone and the PC both onto, for example, a particular port. So if you want to do that, the way you are going to create the topology is going to be like this, and we are going to have PC like that. So it is going to connect here, and it is going to connect from here to here. We also have nowadays software-based IP phone that runs on the machine itself. But if you have a hardware IP phone, this is how like it is going to connect. The IP phone has a 3-port switch in the back. So you can just see it here. The IP phone has a 3-port switch in the back. So one port goes towards the PC. So now, like when the IP phone sends the traffic, to support that traffic, we have to configure a voice VLAN, or we can use other techniques as well, such as untagged, .1p and all. And when the end user sends the traffic, for that we have the access VLAN. So your IP phone will come into the picture, and we have to configure the things on the switches based on the same. based on this kind of topology actually.